Determining the correct ampacity rating for an oven supplied by a single feeder involves understanding the National Electrical Code, or NEC, requirements. An oven with a nameplate rating of 175 amps, when supplied by a single feeder, is generally not considered to be rated at 100% of its nameplate current. The NEC often requires that continuous loads be factored differently than non-continuous loads. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. Firstly, it's important to establish if the oven's load is considered continuous. If the oven is expected to operate continuously for 3 hours or more, then the feeder conductors must be sized to handle 125% of the continuous load, according to NEC section 215.2 and 210.19. This is equivalent to saying that the maximum allowable ampacity of the feeder is 80% of the conductor's rating. Secondly, let's analyze the 175 amp oven situation. If the 175 amp rating represents a continuous load, then the feeder conductors must be sized to carry at least 125% of 175 amps. Calculating this, 1.25 multiplied by 175 amps equals 218.75 amps. This means the feeder conductors must have an ampacity of at least 218.75 amps to comply with the NEC. Thirdly, if the 175 amp rating represents a non-continuous load, meaning it's not expected to operate for 3 hours or more, then the feeder conductors can be sized based on 100% of the load. However, it is always crucial to verify local codes and regulations, as some jurisdictions may have stricter requirements. Fourthly, conductor ampacity is determined by NEC tables such as Table 310.16, which lists the allowable ampacities of insulated conductors rated up to 2000 volts based on the insulation type and the ambient temperature. The appropriate conductor size must be selected based on the calculated load and the specific installation conditions. Fifthly, overcurrent protection devices, such as circuit breakers or fuses, must also be sized appropriately to protect the feeder conductors. The overcurrent protection device should not exceed the ampacity of the conductors it is protecting, unless certain exceptions apply as outlined in NEC section 240.4. Sixthly, voltage drop must also be considered when sizing feeder conductors, especially for long runs. Excessive voltage drop can cause equipment to malfunction and can reduce the efficiency of the electrical system. The NEC recommends limiting voltage drop to no more than 3% for feeders and no more than 5% overall for feeders and branch circuits combined. Seventhly, when dealing with ovens and other appliances, it is essential to consult the manufacturer's specifications and installation instructions. These documents often provide specific requirements for wiring, overcurrent protection, and grounding. Eighthly, the NEC provides guidelines for calculating the demand factors for various types of loads, including cooking appliances. Demand factors allow for reducing the calculated load based on the likelihood that all appliances will not be operating at the maximum rated current simultaneously. However, the use of demand factors depends on the specific application and the number of appliances being served. Ninthly, grounding is a critical aspect of electrical safety, and all electrical equipment, including ovens, must be properly grounded to prevent electric shock hazards. The grounding system must comply with the requirements outlined in NEC Article 250. Tenthly, it is always recommended to consult with a qualified electrical professional to ensure that all electrical work is performed in accordance with the NEC and local codes. Electrical work can be dangerous, and improper installation can lead to fire hazard or electric shock. 11thly, let's revisit the initial assertion. If the 175 amp oven is on a single feeder and considered a continuous load, the feeder ampacity must be at least 218.75 amps. Therefore, stating that a 175 amp oven on a single feeder is rated at 100% is incorrect, especially if it's a continuous load. 12thly, let's consider the scenario where the oven is not a continuous load. Even if it is not continuous, good engineering practice might still dictate upsizing the conductors for future expansion or to reduce voltage drop. 13thly, The NEC also addresses specific requirements for cooking appliances in Article 220. This article provides guidance on calculating the load for household ranges, ovens, and other cooking equipment. 14thly, when evaluating the nameplate rating of the oven, it's crucial to understand what the 175 amps represents. It could be the total current draw of all heating elements and components within the oven. 15thly, the NEC allows for some flexibility in applying demand factors to cooking appliances, depending on the number and type of appliances connected to the feeder. 16thly, if the oven is part of a larger commercial kitchen, the demand factors may be different than those used for household appliances. Commercial kitchens often have higher load densities and more diverse equipment, requiring a more comprehensive load calculation. 17thly, when selecting conductors for the feeder, it's essential to consider the ambient temperature in the vicinity of the conductors. High ambient temperatures can reduce the ampacity of conductors, requiring larger conductors to be used. 18thly, the type of insulation used in the conductors also affects their ampacity. Some insulation types are rated for higher temperatures than others, allowing for higher ampacities. 19thly, the NEC requires that all electrical equipment be listed and labeled by recognized testing laboratory, such as Underwriters Laboratories, or all. This listing ensures that the equipment meets safety standards and is suitable for its intended purpose. 20thly, when installing the feeder conductors, it's essential to follow the manufacturer's instructions and the NEC requirements for conduit fill, conductor bending radius, and support spacing. 21stly, the NEC also addresses the requirements for disconnecting means for appliances. A disconnecting means must be provided to allow for safely disconnecting the oven from the electrical supply for maintenance or repair. 22ndly, the location of the disconnecting means must be readily accessible and within sight of the oven, or capable of being locked in the open position. 23rdly, when sizing the feeder conductors, it's important to consider any future expansion or changes to the electrical system. It may be prudent to install larger conductors than currently required to accommodate future loads. 24thly, the NEC is updated regularly to reflect changes in technology and industry best practices. It's essential to stay current with the latest edition of the NEC to ensure that all electrical work complies with the current requirements. 25thly, the local electrical inspector has the final authority to interpret and enforce the NEC. It's always a good idea to consult with the local electrical inspector before starting any electrical work to ensure that the installation will comply with the local requirement. 26thly, when sizing the feeder conductors for an oven, it's also important to consider the voltage rating of the oven and the electrical system. The conductors must be rated for the same voltage as the oven and the electrical system. 27thly, the NEC provides specific requirements for the installation of electrical equipment in hazardous locations, such as areas where flammable materials are present. If the oven is located in a hazardous location, the electrical installation must comply with the requirements of NEC Article 500. 28thly, when working with electrical equipment, it's essential to use appropriate personal protective equipment, such as safety glasses, gloves, and insulated tools. 29thly, electrical work should only be performed by qualified and trained personnel who are familiar with the NEC and safe work practices. 30thly, the NEC also addresses the requirements for surge protection. Surge protection devices can help protect sensitive electronic equipment from damage caused by voltage surges. 31stly, when selecting surge protection devices, it's important to choose devices that are rated for the voltage and current of the electrical system. 32ndly, the NEC provides guidance on the proper grounding and bonding of electrical equipment. Proper grounding and bonding can help reduce the risk of electric shock and improve the performance of the electrical system. 33rdly, when installing grounding and bonding conductors, it's important to follow the NEC requirements for size, material, and installation methods. 34thly, the NEC also addresses the requirements for arc fault circuit interrupters, or size. SIs are designed to detect and interrupt electrical arcs, which can be a cause of electrical fires. 35thly, FSIs are typically required in branch circuits that supply bedrooms and other living areas. 36thly, when installing electrical equipment, it's important to follow the manufacturer's instructions and the NEC requirements for clearances and working space. 37thly, adequate clearances and working space are essential for safe and efficient maintenance and repair of electrical equipment. 38thly, the NEC provides guidance on the proper labeling of electrical equipment and circuits. Proper labeling can help prevent confusion and errors when working on electrical systems. 39thly, when labeling electrical equipment and circuits, it's important to use durable and legible labels that are resistant to fading and damage. 40thly, the NEC also addresses the requirements for energy efficiency. Energy-efficient electrical equipment and systems can help reduce energy consumption and lower utility bills. 41stly, when selecting electrical equipment, it's important to consider its energy efficiency rating and its impact on the overall energy consumption of the building. 42ndly, the NEC provides guidance on the proper installation and maintenance of electrical systems. Regular maintenance can help prevent electrical problems and extend the life of electrical equipment. 43rdly, when performing maintenance on electrical equipment, it's important to follow safe work practices and to energize the equipment before working on it. 44thly, the NEC also addresses the requirements for emergency power systems. Emergency power systems can provide backup power during power outages to ensure the continued operation of critical equipment and systems. 45thly, when designing and installing emergency power systems, it's important to consider the specific needs of the building and the equipment that needs to be powered. 46thly, the NEC provides guidance on the proper selection and installation of generators, transfer switches, and other components of emergency power systems. 47thly, the NEC also addresses the requirements for renewable energy systems such as solar photovoltaic systems and wind turbines. 48thly, when designing and installing renewable energy systems, it's important to follow the NEC requirements for safety and performance. 49thly, the NEC provides guidance on the proper grounding and bonding of renewable energy systems to prevent electric shock hazards. 50thly, the NEC also addresses the requirements for electric vehicle charging stations. Electric vehicle charging stations are becoming increasingly common, and it's important to install them in accordance with the NEC requirements. 51stly, the NEC provides guidance on the proper wiring, overcurrent protection, and grounding of electric vehicle charging stations. 52ndly, it's critical to remember that electrical codes can vary by locality, and the most up-to-date code should be referenced.